and welcome to the R&D Technologies presentation. This presentation is going to be two parts. The second part is held by Dinesh. The first one by me. I'm going to talk about, give you a short introduction to what XClip is, which is the new feature we have built. And also, if you have any questions, just interrupt me and I'll try to answer them as best as I can. Let's dig in. So what we have done is that previously paper used GDI instead of red, and we wanted to move paper so that it uses red instead, because it would increase the performance, especially for really large drawings. And it also would eliminate a lot of the redrawing that GDI had to do all the time, like when you move the paper a little bit and stuff like that. And what XClip is the new red viewport. So yeah, we have two parts of an XClip or viewport. We have the wormhole and the source. So they work together, and the wormhole is what you see in Paperspace, basically, and the source exists in model space, and it provides the content that the wormholes should show. So the wormhole connects to the source. Another thing about the wormhole is that it can be collapsed. That means that it's not connected to any source. And if it's collapsed, it's obviously not going to show anything from model space. We also have a new feature too, which is that you can connect companions to the wormhole to add certain specific functionalities. We'll talk more about that later. We can also have different shapes of the wormhole. Can have different shapes. Previously, it was only a rectangle. Now you can have ellipses, rects with rounded corners and stuff, and just regular rects, of course. But they plan to be. I'll get into that later. Source is also not visible in model space unless you enter specific view modes. So the view mode will show it. We also have an XClip view mode. And we also have built the edit mode to manipulate the source. The source can also exist in alternative spaces. That's the previous viewport. But now it can also live in different spaces, including elevation spaces, for example. Okay, so I wanted to just show you the basics of it. We have just placed a couple of snappers, and we want to create a new viewport. We have this button, which has all been there before. Now you create an XClip instead. Going to Paperspace, you can see that you have the viewport called XClip here. You can also create it from here. It's a little bit different. You can choose two insert modes. So when I do this, it's going to be collapsed from the beginning. Now it's not connected to the source. In order for me to create a source, I just need to double click and place it. Then we have a new viewport. And we can also, as I said, use another mode where we just enter this directly. Here we can just we can change the scale. We have it a lot bigger, zoomed out. We can obviously attach different visibility settings, so on. And as I said, new feature is that we have different shapes. So let's do the ellipse one. There you go. So you can have different shapes like this, rotate it, and stretch it and stuff. Nice. Of course, how you stretch it depends on which mode it is in. Now the scale is locked, meaning that we also increase the size of the source when we stretch. If we unlock it, the source will remain the same size. Show you here by going to view all. Go back, stretch it now. It won't have size, but if we lock the scale again, this, it's going to be much smaller here as well. So what I entered here is also called the edit mode. You can do a bunch of stuff, not a bunch of stuff, but you can change how it looks and everything. You can rotate it. This can become a bit confusing because you won't rotate it out here. You will just rotate the content. So this one is not actually rotated. But anyway, I wanted to show the improvement in speed. So what you will see here is that on the left-hand side you have a GDI version, and on the right-hand side you have the red version performing the same tasks, although they are not automated. So the GDI will be clicked first, and then the XFlip one will be clicked. But anyway, so we're going to start by just entering paper space from model space, and this is quite large drawing within a lot of snappers and stuff. But what you see is that GDI was still loading until when the red one finished. And what we did here now was that we selected we just went to a different page with 3 of these viewports. So we have already clicked the GDI. We did that before the red one, but the red one has already finished loading. The GDI is still continuing, and it takes a while. Yeah. So you can there you can see like the huge benefit of using red in paper space. And continuing with like an abstract image of what the structure is. So you have the source and the wormhole, as I mentioned, and they refer to each other using snapper references. And what the source does is that it provides a shape to the wormhole through a shape vessel. And it also holds colors, which the wormhole uses to retrieve the contents. So in the wormhole, you can see we have a content class, which holds the visibility settings, but also clipped scene and unclipped scene. We'll come back to that a bit later, but that's what we are showing. We also have the companion connector, which companions can be connected to. So let's go into companions a bit more. They are shown in Paper Toolbox. You can connect them to a wormhole in order to provide specific functionality. The quick properties can be accessed by either clicking the companion sometimes, but if not, you can access them through the wormhole's quick properties. There are 2 types of companions right now. The more simple one is the graph additions. So they will add things you see on the wormhole, like a frame or scale or something like that. And we have editors which will manipulate the contents of the wormhole. And its companions are made to be quite easy to create, especially the graph additions. The editors will be more advanced, but still not impossible. So we have few default companions, the scale, the frame, column balloons, which I will demonstrate, and also a tag plot style. I will show you all these now. New page, create a wormhole. And so we would like a frame. Let's just put it on. Okay, nice little frame. We want to see the scale. There you go. Color balloons is also said a new feature to this. So if we go back into the tools tab, we can place a couple of balloons. There. Also baseline, something like this, and what we can do now is that we attach all the balloons to this. It will measure distance from the column balloons to the baseline. And, this can be used in a bunch of different ways. We also have the only current editor, which is the part tag. To these snappers, I've added some different part tags. These and these. Okay, now in the viewport, we can just add this. See that they will get their correct color. Of course, when you do that, you can. I didn't show that. You can access the tag plot style quick properties from this drop down. Here you can also select which category you want to show the color of. But now we only have one category. I can only show that. Yeah. Continuing. Oh wait. I wanted to show a small example code. Where's okay. So this is a super small companion I've made who does one thing. It adds text C experience to the upper corner, right hand corner. And it took me about 10 minutes to make. Of course, it's not very advanced, but can you see it by the way, or is it small? Too small. Pretty bright as well. Yeah. So we have a few different things here. The companion key needed so that the wormhole can find its companion. We also have the label. We have the method contains, which is actually forgotten here. It's not needed, I believe. We have the build 2D, which actually places the text and everything. And you can see that what's needed is basically I just create the text, retrieve the bound, I retrieve the shape, the bound of the wormhole. Set text to the GS, and then I just transform it to get it in the correct position. Nothing difficult about that. And we also have a toolbox image. And this is all you have to do. Well, you need to do this as well. You need to call this method to to register your companion. But once you do that, it will show up in the toolbox along with every other companions, and you're good to go. This is quite a simple example, as I said, but really the scale is not much more difficult. Um, the ones that are going to be difficult to implement are the editors, because yeah, they do a lot more. Um, anyway, yeah. So the content and scenes. As I said, the wormhole owns the content. Uh, the content contains two scenes and visibility settings. One of the scenes which is clipped and unclipped. And it might be good for you to know that the scenes holds a repository, red repository. So we have a couple of planned features. The first one is the clipped and unclipped scene. Much of the code is already there, but the unclipped scene is not really used right now. But the idea is that when we have snappers that are placed on the line, and it can be like dimensions as well. Go outside the wormhole, then they could be chosen to be unclipped, which would mean that they would just go outside the wormhole in paper space as well. So with that, we hope you can do a lot of different things, perhaps draw dimensions between wormholes, or just play around with it and see if you can find a good use case for it. We also have the move/edit graphs without changing model space. What this is basically, I would say that it's an alternative for the wormhole. So in alternative spaces, we create one for the wormhole. What we would do is basically just enter edit mode and like move a snapper, and then it would be moved in the wormhole, but not in model space. So just in the wormhole, and yeah, so the wormhole doesn't really reflect reality anymore. It might be useful to like move away stuff that's in the way, or delete it even, to show what you really want to show. Kind of a small quick filter or something. Yeah. We also have shapes, as I said. They are held by a shape vessel, which is attached to the source. It's easy to create and register a shape. Most of the work that's done in shape is done in a method called polyline 2D. And basically what we need you to return there is just an apolyline 2D which defines the shape. Then you also have a method called fitBound, which takes the rect, and what should happen then though then is that your shape should kind of expand to that bound. And we also have a planned feature, the custom shape, which is that the user themselves should be able to just hand draw a shape, kind of like custom shapes, and save it, use it further down the line. Any questions? Yes? Oh, yeah, sure. Oh, we have ISO mode on this? Yeah. Tag should be Oh, switch. Uh, yeah. So that this is basically used at least by a companion, and it's a bit more work than just adding CET experience in the upper corner. But you can create them yourself, and it's not all that much work. I'm not particularly familiar with this code, so please.
All right. So what this one does, what the main function of this one that you're interested in is if you want to manipulate the viewport, add and change the graphical representation of anything in your viewport, you use a content editor. It's a extra content editor. What you get with that is that you get this message right here, which is edit. For every graph that you have in your viewport, you will get here. You can now manipulate that in any way, changing line weights, changing colors on the fill colors, removing fill colors, and so on. We have two of these. It's the black and white, and it's the tags. Basically, what you can see, this one is just taking the fill color of the graph and changing it to the tag. That's what you see. I think this is a very useful content of viewport where you can start doing things. Right?
Yeah. All right. I mean, continuing to the next part. Hmm.
Paul, is this okay? Hello, testing, testing. Okay, good morning. I'm Dinesh, and I work as a developer for Configura at our office in Kuala Lumpur, Malaysia. And today I have two new features that I'd like to present to you, which are lazy extensions as well as IFC import and export, which is basically a refinement of the existing IFC import and export functionality. The outreach of these features is obviously very different, as lazy extensions is a pretty big change to the extension system, meaning it will most likely affect almost all, if not all, developers who work on extensions in one way or another. Whereas IFC import and export is a very specific functionality that will most likely only affect individuals who wish to have some form of integration between CT Designer and IFC. My little objective for the presentation today is to provide you with a surface level explanation of these features to hopefully encourage you to have them implemented in your extensions, and as a whole inch closer towards the grand goal, if you will, which is to propel CT Designer to greater heights. So these are some performance benefits that you get with these improvements. So we'll go to them slowly. I have some content. I also have some demos, and I will take questions at the end of the session. We'll start with lazy extensions. Before we can truly dive into the essence of lazy extensions, I think it's important for us to first understand extension events, because extension events or understanding extension events will give us uh, some clue as to why lazy extensions were developed in the first place. So let's look at extension events. If you have worked on extensions before, all of these terms that you see on the screen would be fairly familiar to you. An extension is home to a set of events. I've simplified the list to just 4 distinct events, which are initialize, start, stop, and terminate. These events are managed by an extension manager that resides in core. The initialized event is called once per extension, and the start and stop events can be called repeatedly throughout the lifespan of an extension. I usually think of them as groups, where the first group would be initialize and terminate, and the second would be start and stop, primarily because you would usually perform some operation in initialize and have that reversed or undone in terminate. And the same goes to the start and stop group as well. Let's now dive a little deeper into extensions or extension events to see what we use these events for. Initialize, seeing as it's called once by the extension system, makes it the perfect candidate for initialization of resources or of databases and those sort of operations. We use the start and stop events sometimes to register hooks or to register, say, shortcuts. If you want the shortcuts to only appear when the extension is turned on and you want it to disappear when it's turned off, you can put them in the start and stop events. And you would use terminate sometimes to clean up some of your resources. And if you have a set of lightweight events, you would most likely end up with a fairly speedy extension in terms of startup time. But let's be a bit more realistic here. We've all worked on extensions before. We all know what sort of events or what sort of operations we end up adding to our events. We normally don't just stop at initialize resource. We'd normally start adding in stuff like initialize schemes or pass some files or establish a connection with a server or maybe even begin downloading catalog objects. So that adds a few seconds to your initialization process. And the same behavior trickles down to the start method and the other methods as well. This is not a significant change in terms of your extension. If you end up adding 2 seconds maybe to your extension, it's not the end of the world. It's still fairly fast. You don't really see a lot of downsides to it. But when working with CET Designer, it's always super important to keep in mind that users would normally have 10 to 15 extensions installed at a time. So if each extension ends up adding 2 or 3 seconds to its load time, the user is going to experience a horrible startup time, right? And that's what we want to avoid. And it becomes really frustrating for the user, especially if he only wants to use extension A. If he wasn't intending on using extension B and C, why would we have to spend precious load time initializing resources, initializing databases, and establishing connections with servers and such for extensions B and C? It adds no value to the user's experience, so we're basically just wasting time here. And that brings us to laziness. Are you guys familiar with laziness at all? This concept exists in various parts of our system. The idea behind it is to only really perform an operation when you absolutely need to. You try to procrastinate, you try to delay an operation for as long as you can. And that brings us to this question. What is the furthest we can postpone the initialization of an extension to? Does anyone want to try to guess? Anyone? Exactly. Exactly. So when you click on an extension toolbox, it obviously means you want to use the extension. At that point, it's pretty obvious already. So we try to delay it all the way up to the point where the user clicks on the extension toolbox. So let's try to visualize that. We have 3 extensions that are fast asleep. When I say asleep, I mean these are just extension containers, or empty containers, stubs, if you will. No initialization code has been run on any of these extensions. These are just placeholders. And when the user clicks on an extension, in this case extension B, only then do we run the initialization code. Only then do we start initializing your resource files, your databases, and your catalogs, and so on and so forth. Extensions A and C remain fast asleep. They still exist as just mere containers or stubs. So this idea of laziness gave birth to this whole concept of ultra lazy extension. So this extension system relies heavily on a lazy.xml file. This file sort of drives the laziness of an extension. So before, the CET Designer system would go through all the extensions that need to be started up, and it will try to initialize all of them. So it runs the initialize method, it runs the start method, and it has them all ready for use. Whereas now, CET Designer is going to run through all the lazy XML files, parse them, and create extension stubs for you. So no initialization code is run, the extensions are not started, and you just have a bunch of stubs ready to be used or ready to be clicked on by the user. And only when you click on the extension do you initialize the extension and prepare it for use. Does that make sense? Yeah. So that's a pretty distinct difference from what it used to be. Let me show you a quick demo. I have Okay, so I have an extension that I've created that is really slow. It takes 12 seconds to start. I basically put it to sleep for 12 seconds, and as soon as it's initialized, it will add 12 snappers to space. You will see that when I start uh, my software, the space will remain empty, and there will be no distinct delays in the startup time. So it starts up fairly quickly. So now I have CET Designer up and running. I have several extensions over here, and I can also show you extension, ultra, lazy extension data, and I just prepared this little dialog. Not sure if you can see, it's small, but it shows me the states of all of these extensions. Right now, all the extensions are asleep. It will turn green as soon as the extension is started up. So when I click on my toolbox, this is the demo extension that I've created. This is the demo extension. When I click on it, it's going to load it's going to run the initialize method, which will take 12 seconds, and it will then add snappers to space. So it loads for 12 seconds, super slow extension, horribly written. And now we get 12 snappers, and the extension has been awoken. So it's now wide awake, and every extension still remains fast asleep. So let's just look at the code. This is nothing fancy over here, just a regular init function, adding snappers, making it sleep, creating snappers, making it sleep, and then adding them to space. Okay, so that was the basic idea behind lazy extensions. Let's now quickly look through the lazy XML file. As I mentioned earlier, this is the file that drives the laziness of an extension. You could create a very simple XML like this, which creates an extension stub for you. You have the package, which the extension belongs to. You have the library file that creates the extension toolbox, and you also have a label. If you're familiar with groups, you can also use lazy XML to register your groups. So there's no need to add all of this group code to your initialize or start methods anymore. You can control the visibility of your toolbox through the lazy XML file if you want it to appear only to developers, or if you want to restrict it to certain channels, that can be done. And you can also add triggers. You can add multiple triggers to your extension. A trigger is used to forcefully wake an extension. Let's just say there's a functionality in call that requires an extension to be woken up when the trigger is called. Call could send out. Do you have a question? Yeah. Yep. 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 Yeah. Right now, there's no proper documentation in code, but we have all of this documented on the wiki. So we have examples, and these examples are also used extensively in our free extensions. So you could go through Fika, you could go through all of the other available extensions, and all of them have already been migrated to Lazy. So you can look through those. No problem. So we have triggers. You can forcefully wake an extension up using a trigger. My extension has a trigger key, which is some trigger key. And if I were to run this function, trigger lazy extensions, my extension would be woken up. I can show you how that works. Okay, so at this point, all my extensions are asleep. Everything is gray. And if I run this function, it obviously waits for 12 seconds. And now it's done. It says it's done, and it's been woken up. So the trigger can be used to forcefully wake an extension. Right, so that's all I have for lazy extensions. Before I wrap up, I think it's important for you to note that this behavior works exactly as how I presented in develop mode. But for users, obviously, it's not so nice if they have to wait for a certain number of seconds each time they click on a toolbox. So we have a patience threshold function in code. For developers, the patience threshold is 0. So there's no patience whatsoever. Everything is made to sleep from the very beginning. But for users, I think the threshold is about 2 minutes, if I'm not mistaken. So it tries to load all the favorite extensions, all the frequently used extensions, and anything else within the first 2 minutes, and everything else after is made to sleep. Okay, that's the expected behavior with lazy extensions. We can now move on to IFC import and export, which is a pretty small change to the existing system. Is anyone here using the IFC import export system that we have in place? Does anyone work with IFC? Yes, awesome. Okay, so IFC stands for Industry Foundation Classes. It's basically a standard that allows for effective exchange of data between BIM software. And CET Designer has supported export and import for several versions now. It's nothing new. But the way it used to work was like this. You would export a specific snapper, like a chair or a flight of stairs or a door. And once this gets exported to IFC, all of that information, all of the properties that were specific to these snappers would be lost. You now have generic IFC symbols that appear as just a regular furniture object in IFC. And that used to be fine, but of course, you would sometimes want to have a specific object in IFC. You wouldn't, if your door has a knob on the left side, you might want that to persist when it's already been exported to IFC. You don't want it to just be a dumb model or a generic model, not dumb, generic model. But now you have the chance to register your own or use your own export factory to sort of get the properties to persist on export. So now I can export my flight of stairs and have it appear as a specific IFC stair symbol. And same goes to my door. I can export my door and have it appear as a specific IFC door object. I have 2 examples for you. Desktop. So I have a generic door. So this snapper uses the regular export. It doesn't have any specific, any fancy export to it. And once it's been exported to IFC, I would get this, and it would show up as a generic furniture. I'm not sure if you can see it, but it says furniture here, and the icon is that of a chair. No other properties persist from CET. But if I were to do the same export on a specific snapper, I would end up with a door object with a door icon, and I can also send some properties like single swing right over here. You can pass more properties to it based on the IFC interface. And using the IFC export space custom demo extensions, IFC export. and it's actually really easy to use your export to use your export factory. You just check to see if the snapper is whichever snapper you want to deal with, and then you can map it to a certain export factory. And we have examples of this export factory in several parts of our system. We have it in stairs, we have it in building mechanicals, I believe. So you can look through those examples, figure out how to do this. And the same goes to the import functionality. Previously, if you were to import a generic IFC symbol, it would appear as, or if you were to import any IFC symbol, it would appear as a generic IFC, a generic IFC snapper in CT Designer. So if I were to import file import generic. So here I'm trying to import a generic IFC model. At this point, it shows up as an IFC symbol snapper. So it doesn't know that it's a door. I can't do any door things to it. I can't stretch it if I need to, and I can't do it. I can't adjust any of its properties anymore. But if I use a specific importer, then I can translate it to a specific snapper in CT Designer. So now this guy is represented as a specific IFC door snapper, exactly what it was before. Does that make sense? And the importer is also super simple. IFC import. Okay. So this is all you need to do. You just have to construct a new snapper, adjust it to the properties that belong to the IFC symbol, and you should be good to go. Okay, that's all I have. Do you have any questions for both me and Bjorn? Yes. Mhm, mhm. Yes, that will. There are certain conditions in which extensions will wake up, and those are documented in the wiki. Yes. Yes, they are for 10.5.
Not that.
Okay, I think that should wrap it up. Thank you so much for attending.